Hello, my name is Patrick Kelly and welcome to Fundamentals of Solid Software Design. What we're going to talk about today are the 5 keys to success in solid software design, the project phases, some outsourcing tips, and helpful resources. The goals of this presentation are reducing the cost of test and how using solid software design can help you reduce those costs. So, the 5 keys to success in software design. The first one is understanding the cone of uncertainty, which we'll talk about later. The second is using project management best practices, and we'll go over some of those. The third is to create precise documentation of the test system requirements and to get those requirements from all of the stakeholder perspectives, and we'll talk in a little bit about that. The fourth is to employ a qualified team of developers, and the fifth is to select a scalable software architecture. So this PowerPoint is going to give advice and tips on each of these 5 keys for success. So the first step is to make your test project a success by understanding the cone of uncertainty. And this is a slide that CalBay uses very often to talk about how the project size can change based on what phase we're in. So when we're in the concept phase, the project size might be 4 times what we expect, or it might be 25% of what we expect. But as we go through and gather the requirements and get to a specification phase, we start to narrow down that project size to where we have a much better understanding. And then once we get into the design phase, where we've had our preliminary design reviews and our critical design reviews, we start to really narrow that scope so that the project size, as we go forward, if we're managing it right, the project size gets tighter and more narrow and easier to manage from a budget and schedule standpoint. So as we go from concept to specification, design, implement, deploy, that project size is getting more narrow every step along the way. So when we understand this cone of uncertainty, it helps us in managing our project. And as many of you know, the 3 constraints of project management are cost, schedule, feature set. And a lot of people say pick any 2. The reality is really you need to pick 1. Am I going to manage this project based on cost? Am I going to manage it based on schedule? Or am I going to manage it based on the features? In choosing one constraint, it makes a big impact on the other 2. If I manage a project based on a very tight schedule, I know cost is going to go up. And usually if I manage based on a tight schedule, feature set's going to go down. So I can choose what my second priority is going to be. If I choose schedule as my top priority, I can choose whether cost is going to be the second priority, in which case I need to shave off more of the features, or is feature set going to be the second priority, in which case cost is going to go up because I'm going to need to have more people working on it and probably buy more tools off the shelf. From a project management best practice standpoint, we need to spend the proper time up front on the design and architecture. This goes back to the idea of the cone of uncertainty. The only way to make that project more manageable in terms of budget and schedule and an understanding of budget and schedule is to spend that proper time up front on designing and the plan of what is it we're going to accomplish and the architecture for how we're going to accomplish it. The second best practice is to break the project into manageable components. And again, rather than just assigning this vague task of a test software project to a single engineer and saying, go get it done, a much better practice is to have a senior architect break the project into pieces and hand those pieces off to team members who have experience with each piece. And some of those team members may be in-house staff, some of them may be outsourced, and sometimes those pieces may be tools that you can buy off the shelf. And so that leads to the third best practice, which is do a build versus buy analysis on every single component. Every component that you've broken into pieces, we should look at what will it cost us internally to build this, and we should do some searches online or ask around to see, has somebody already built this kind of software or this kind of tool, and what is available for me to buy off the shelf, and what's the price of that versus building it in-house. So from a test project phase standpoint, the first phase in any project is the specification. And here we're answering the question of what the system must do. And again, we want to take into account all of the stakeholders. So some of the stakeholders are going to be operators that might be pushing buttons on the system. Some stakeholders might be technicians that are going to run troubleshooting. Some stakeholders may be the engineers that are going to look at test data. Some stakeholders may be certain managers that are going to look at yield data or macro data. There may be stakeholders in the IT department that have to deal with how these computers get networked and how does this data go into databases or link in with ERP systems. So again, we need to take into account all of the stakeholders. The second step in the specification is to understand all of our interactions with the device under test. So what are all the analog and digital signals that are connected to it? What are the specifications of those signals? Another key aspect of the specification process is to define our use cases, our processes. At CalBay, we like to write initial user manuals with screenshots of what is the software going to look like when it's finished, and to do this before we actually start writing code so that all of the stakeholders can have a chance to review what the screenshots would look like and give their feedback on what additional buttons or features they'd like to see in the software. A key aspect of the specification is to have well-formed requirements. These are requirements that are capable of acceptance test. So that means that with any given requirement, I can read that requirement and say, this is meaningful to me and I know how to test this. I know how to validate whether this requirement was met. The next phase in our test project is the design and the design reviews. So after we've taken the specification, now it's time to come up with a software architecture, a system architecture. What are the instrumentation we're going to use? What are the tools like LabVIEW or TestStand we're going to use? And come up with this design. What we like to do at CalBay is have from the kickoff meeting, we have some amount of time to write that design and have a preliminary design review, or PDR. And up to the point of PDR, we may be doing some risk prototyping. We may be addressing all of the risk we see in the project and trying to either write some software or look for ways to mitigate those risks. And then by the time we get to a PDR, we're talking about not just the project plan and the use cases, etc., but we're also talking about what are the risk items that are still outstanding, what have we done to address those risks, and what do we need to do. Then at the PDR, all of the stakeholders come together and they say, this is what I like about this design, this is what I don't like, this is what needs to be fixed. And we go off for some period of time, maybe it's a week, maybe it's 4 weeks, and we come back to a critical design review. And the idea with the critical design review is that at this point all of the requirements are frozen. We are showing what the system is going to look like and everybody is agreeing on the path forward. Of course, at that point, after we've had the critical design review, it's time to do implementation. And now we have a very clear plan of what everybody needs to do, how long it's going to take, and how much it's going to cost. After the implementation is done, we do a validation and acceptance test. And again, if we've written well-formed requirements, we have a checklist of how we're going to do the acceptance test. And then once everything has been validated, then we have a delivery of the system. So these are general purpose test project phases that are used from project to project. So again, one of our best practices that we've talked about is the requirements gathering phase. As we said before, we need to create precise documentation on what the requirements are. And when you're looking at requirements for a test system, there's usually 10 different categories of requirements, and that includes software architecture requirements, software tools, hardware requirements, instrumentation requirements, reporting, etc. The details of this kind of requirements gathering is way beyond the scope of this PowerPoint. There's been lots of books that have been written on this. One resource that we use and that CalBay created is called justtestprojects.com. It's a free resource to document your requirements. It asks a number of questions to give you a 360-degree view of your requirements from all of your stakeholders, and it allows you to communicate with the rest of your team, as well as allowing you to communicate with external vendors if you want a competitive bid. One of the issues with solid software design and test is that it requires knowledge in a variety of disciplines. For example, you need to understand programming languages, and this might be Visual Basic, LabVIEW, C, C#, .NET, etc. You need to understand test architectures. These might be test executives like TestStand. You might be using other tools to sequence through the test. But this is sort of a discipline all in itself, and it does not tend to be taught in colleges. You need to understand instrument control. So this might be GPIB, VXI, PXI, LXI, USB, RS-232. How do you talk to instruments? How do you send commands? How do you receive data? You need to understand databases and reporting tools. So when we're storing the results from our test, how do we store that data, and then how do we generate reports for engineers or managers? Obviously, we need to have DUT-specific knowledge, so we need to understand all of the specifics of what we're testing, the unit under test, and how to control it, and what are the requirements for testing it. On a typical test software package, we need to do a lot of math and statistical analysis, waveform analysis. We also need to do graphical user interfaces. We need to understand how to design graphical user interfaces that are user-friendly and that take advantage of the modern tools like LabVIEW and Visual Basic. We need to understand software architecture methodologies. And then finally, how do we connect to third-party tools? We need to be able to connect to ActiveX components, .NET tools. There may be other outside Windows applications that we want to talk to. One of the keys mentioned is to build a scalable software architecture. So when we talk about this, we're talking about building your house on rock instead of sand. The idea here is that choosing the wrong software architecture is almost as bad as building a house without an architectural plan. And what you want to make sure is that some member of your team has experience with software architecture. And if not, you want to hire a consultant that can help you get this right. You want to at least have a plan before you start writing the code. One of the things that you want to look for are certified LabVIEW and TestStand engineers if you are going to hire a consultant. So again, a key item here is you don't have to reinvent the wheel. There are lots of tools and books that you can leverage that talk about scalable software architecture. And LabVIEW ships with many architecture examples. So these things are already out there. You don't have to reinvent the wheel. For a real-world example of an architecture, many Calbe projects use the following. We use TestStand as our test sequencer. We use LabVIEW as our programming language. We will use certain architectures that ship inside LabVIEW. One example might be a queued state machine. And then we will use a test data management tool off the shelf, such as IntraStage or Diadem, or a combination of those. For those who know LabVIEW, you know that it speeds up development time and test. If you're doing a test project and you do it in LabVIEW versus C or Visual Basic, you're going to get a tremendous development time increase. In addition, we choose TestStand because it allows an off-the-shelf sequencer, and there's documentation already for the best practices for using that sequencer. And then tools like IntraStage and Diadem allow us to have an off-the-shelf test database and reporting mechanism so that I can combine TestStand, LabVIEW, IntraStage, and Diadem, and I can have a system that is ready to go with best practices and architecture, many of those pieces already done for me. So this next slide talks about why some clients outsource. Most customers are focused on improving the designs and the profit margins of their products. Automated tests for them is a necessary evil to achieve this goal. In R&D, they use automated tests for characterization. In production, they use functional test systems and debug stations. Many clients also need to support field tests. But again, the client's core competency tends to not be automated test system development. So the in-house staff may be lean, and that client may look for an outside firm to know the latest technologies and best practices. And again, one of the other benefits of looking to an outsourced firm is this firm can be around later to support you after the initial project is finished and you need long-term support. So the top 5 considerations when choosing an integrator: you want to look for somebody who has a knowledge of the tools and technologies. So in the case of tests, you want to find people that have LabVIEW and TestStand certifications. You're looking for a company that has solid processes for software development. You want to talk to them about what are the processes you use for source code control, for bug tracking, for bill of materials tracking, etc. You should be very interested in the long-term support capabilities. If I do an initial phase, it's 2 months of development, and then I want to expand that later 6 months down the line or 1 year down the line. Is this firm going to be around to support me in that? Another key consideration when selecting an integrator is their past industry experience or their application experience. So you'll want to look at what has this integrator done in your industry, what applications have they done similar to your application. And then finally, what's the track record of success on past projects? Can you get a list of references? Are there people that you can call that have worked with this vendor? Again, one thing to consider is that 3 references are pretty easy to put together. if an integrator's been working for a number of years, it's not hard to come up with 3 references. So what you really want is not so much 3 references from anybody they've worked with. You want to have 3 references from people in the industry that they've worked with or applications that are similar to yours. So in summary, the 5 keys to minimize your test software cost. The first is knowing and understanding the cone of uncertainty. The second is using project management best practices. The third is to create precise documentation of the test system requirements. The fourth is to employ a qualified team of developers. And the fifth is to select a scalable software architecture. So as we mentioned before, some additional resources. The first is ni.com/training for you to find classes and get certified. If you have engineers in-house and you want to get them some more training or you want to get them certified in LabVIEW or TestStand. Another resource is LabViewJobs.com. LabViewJobs.com can help you if you're looking to hire people. You can find certified engineers there. Another resource, obviously, is Calbay.com. Of course, that's our company, and we build turnkey systems and provide on-site support for LabVIEW and TestStand applications. Another resource when you're doing this build versus buy analysis is JustTestToolkits.com. These are third-party tools that can allow you to do your system integration faster. And as you look at the project in the design phase, as you identify which components should be built and which components should be bought, Just Test Toolkits is a resource to find some things that may already exist that you can buy off the shelf. Another resource that we talked about here is Intrastage.com, which is a test data management solution for storing test data and generating reports. And Intrastage links in directly with TestStand and LabVIEW and also with Diadem. And I encourage you to visit Calbay's online booth for flash demos of many of these things. Again, my name is Patrick Kelly with Calbay Systems, and I appreciate your time in listening to this presentation, and I wish you the best of success in designing your own solid software.